Alright, working on the key for our workshop number 2 from Unit 2. So the first thing I would do, in these cases you are given the actual compound there, I would redraw it. I would redraw it in that kind of stick figure way. I was like to do that because I think I can see it better that way. So this tells me I have an alkene. Okay. When you're given the structure like this, what I will do is I'll look at this first and then go to the IR to find which peaks make sense. So here I would say, I know I have sp2 hybridized CHs. Right? That's what these are, sp2 CHs. And sp2 CHs are always above 3,000. So I would say, I'm not sure, 3,700 million numbers. Basically, this peak, I would say, is a CH stretch, but it's that sp2 CH stretch. This molecule also has a bunch of sp3 CHs, so I can label those. So I would say another thing I would have on here is an sp3 CH, and these are all below below 3,000. So I just say 2950. So I could circle these and say those are the sp3 hybridized CHs. Right, the sp3 hybridized CHs. The other thing that's tough here, there's not much else going on, but you can look at your table on your one of the handouts we gave you, table 13.5. You notice we have a terminal alkyne, meaning there's two CHs at the end, and it's di-substituted. So an alkene can be mono, di, tri, or tetra-substituted. In this case, it has two, so it's di-substituted, and it has two H's on the same carbon, so it's di-substituted and terminal. And then I look at that table, and that table says a di-substituted terminal alkene should have a peak at 890. And that would be this peak. Right? This is at 890. And this tells me I have that terminal di-substituted alkene. Another peak you can look for is around 1650. That's this. This is that CC stretch. So I would say 1650, and then on that table, that 1890, it's a bend technically, 1890 tells me I have an alkene. 1650 tells me I have an alkene. The 890 tells me exactly what type of alkene I have. A terminal di-substituted alkene. Good. Alright, for this one, everything's kind of already drawn out for us. So we have an aldehyde and a benzene ring. So if we remember, we look back at our aldehydes, there's a special stretch, or two stretches, right? Again on table 13.5. You see these two peaks right here. They are, let's see, they are exactly 2820 and 2720. That's that aldehyde CH right there. So that's what that represents. That CH of the aldehyde. Okay. So we know that's one really indicative one. The other thing you notice, we have some stretches up here that are beyond 3,000. Right? So these would be 3050. And those are going to be my sp2 CHs. Right? The benzene ring has sp2 CHs. Hydrogens off sp2 hybridized carbons. So sp2 CHs right there. The other thing to look for, here's that C double bond O. This is actually a little lower. It's at 1710. Normally aldehydes are a little higher, but this aldehyde is part of a conjugated system, so there could be resonance, so it's going to have more single bond character. So it's going to have a lower frequency. And that's for the COO. You can see that on the specific IR table, or table you're being given. When it's alpha beta unsaturated, we consider this alpha beta unsaturated. There's resonance there, so it's more single bond character. Then also you can look at, see where benzene rings are found on table 13.4, and benzene rings are around 1600, and you'd have a stretch around 1460 in this case. So that would be these guys represent the benzene ring carbon-carbon aceto bond O stretches. So that represents the benzene ring. Again, for this one, I like to redraw it. An H and an OH. So what do I have here? I have an SPCH, which you can kind of see this point right here, this SPCH. That's probably for that. SPCH, and that's around 3,200, maybe a little higher, 3,250. And it's kind of getting covered up by this big peak, which of course is our OH, so it's kind of hard to see that. So that OH stretch is there. So that's a big kind of range, kind of from 3,500 to all the way to 3,100. So this was that SPCH. This is that OH. What other kind of functional groups do we have in here? We have an alkyne. So where do alkynes come at? The triple bond region is 2100. Alright, so we kind of have these regions where this is kind of C, this is a double bond region. Around 2200 is a triple bond region. And that represents the C triple bond C. So that carbon triple bond. That's that peak right here, which represents that stretch. There you go. Okay, for this one, I've kind of already got it done for you. Things to look for. If you have a redrew our molecule, first thing you should notice, looking for function groups, and NH. This is a broad peak. It looks similar to an OH. You probably wouldn't know it was an OH or an NH, but since we give you the molecule, it's a little more clear. That's around 3,300, so that's an NH stretch. We also look at the molecule here. We have sp3CHs, so we should see a stretch around below 3,000, 2950 for the sp3 CH stretch, sp3 hybridized CH stretches. We also want to find the aceto bond O stretch, and for an amide, that's lower because this can do resonance, so there's more single bond character here, so the lower frequency, and that's around 1660, so that would be the CO of the amide. There's also an NH bend. Now this is a stretch. This is the bend. The bend comes in at 1560. And these are all available on your tables, of course. And that represents the CO single bond stretch. So if there's not a lot of functional groups, there's not going to be a lot of stretches.